Okay, so today on notes 1, 2, we're going to be solving one variable linear inequalities. An inequality is like a less than or greater than, a less than or equal, or greater than or equal. So this is very similar to what we were doing yesterday, except we don't have an equal sign here. So we're still going to solve it the same way, but you have to remember, and it tells you at the very top of your notes, so you might want to highlight or star. It's already underlined for you. You need to remember when you're dealing with inequalities, if you multiply or divide by a negative number on both sides, you will have to switch your inequality sign. Okay? All right, so again, we're going to solve it the same way. So we're going to find x, and then we're going to graph the solution on the number line. Okay, so let's look at number 1. So notice that we have variables on both sides. It doesn't matter, we talked about yesterday, it doesn't matter which side you move your variable to. Okay, so I'm going to move 3x to the right side, so that way it stays positive. So I'm going to subtract 3x on both sides. So I'm left with negative 2 is less than or equal to 2x minus 3. Okay, so my next step, I'm trying to get x by itself, will be to add 3. And you have 1 is less than or equal. Those cancel, so you're just left with 2x. And then we're going to divide both sides by 2. So we have x is less than or equal to a half, and leave it as a fraction. Okay, now there are, you can rewrite that answer if you want the variable on the left side. So if you were to do that, so write your variable on the left side, notice this inequality here, it's opening to the x, so that's how it needs to stay when you're rewriting it. So x is greater than or equal to 1/2. So box in your answer. Now we're going to graph it on the number line. So on this number line, I always want you to put the 0. So that's going to be in the middle. And then I also want you to put the number that is on your solution here, so which is a half. Now, when you're having to graph inequalities, you have to use an open and a closed point. Anytime it includes the number in the solution, you need a filled in point, so that's equal to. So make sure you're writing that on your notes. If it's not equal to, it's an open point. My bad. Okay, so not equal there. Okay, so it says x can be anything greater than or equal to a half. So we're going to have a filled in point on the half because it's equal to a half, so make sure you fill that in. And then I want you to draw an arrow the direction that your solution is. So it's everything greater than that, so it'll be an arrow to the right. So that's how I would like you to graph. So to check this, just like yesterday we talked about, you could plug in, make sure it's true. Same thing here. Plug any number in that's greater than or equal to a half in for x, and it should be a true statement. Okay, so let's take a look at number 2. So notice this one, we only have one variable, so we're trying to get it by itself. So first step here would be to subtract 4 on both sides. You have a negative 2x, make sure you bring that negative down, is greater than 6 minus 4 is 2. Okay, so now I'm going to divide both sides by negative 2. Remember, I told you at the beginning, anytime you're dealing with inequalities, if you are dividing or multiplying by a negative on both sides, you must change your inequality sign. So what I like to do when I divide right here and I put a negative sign here, I like to go ahead and circle that there, so that way when I'm rewriting it, I don't forget if it's circled, I need to change it. So that's going to be x is now less than, and then when we divide, that equals negative 1. So there's my solution. We could plug anything in that is less than -1. Okay, so I'm going to plot my 0, and then my solution includes -1 there. But notice it's not equal to -1. It just says x is less than -1. So on -1, you need to have an open point. Everything less than would be to the left. Now, if you're struggling with which way the arrow needs to go, if you don't remember your inequality signs, then if your variable is always on the left side, if you look at that inequality, it should be going the same direction the arrow is on your inequality. Okay, so number 3, notice it's different than number 1 and number 2 because it has parentheses. So we talked about yesterday, if we have parentheses, we will have to distribute. So that's going to be 16x minus 8 is greater than 11x minus 17. Okay, so now we got rid of the parentheses, and now we're going to move our variable to one side. Again, it doesn't matter which side you move your variables to. So I'm going to subtract 11x. So we have 5x minus 8 is greater than -17. So next step would be to add 8. And you have 5x is greater than -9. Then we'll divide by 5. We don't need to change the inequality sign here because we're not dividing both of the sides by negative. So that would be x is greater than -9/5. Okay, so graphing, we have our 0. -9/5 will go on the left side. Our solution will include any number greater than -9/5, but not equal to -9/5. So we need an open point on -9/5, and everything greater is to the right. Okay, let's take a look at number 4. So again, we'll have to distribute. So that's 5x minus 10 is less than or equal to 7. So we'll add 10. So we end up with 5x is less than or equal to 17. And then we'll divide by 5. So we have x is less than or equal to 17/5. We can't reduce. So we will plot our 0, 17/5. It does include it, so it should be a closed point at 17/5. And everything less than would be to the left. Okay, so the front page was just solving one variable linear inequalities. Let's look at the next page, or the back. Okay, so on the back, we're going to have still some inequalities, but they look a little different than the front, okay? Sometimes you'll have conjunctions and disjunctions, which are types of inequalities. A conjunction, it says, is an and statement, which means all together. A disjunction is an or statement, which means it will be separate. So it'll be separated by an or in between. So and is all together, or is separate. Okay, so on number 5, we have an and statement. So it's all together. We're still going to solve it the same way. So for right now, I'm just going to mark through this. If we had that, that was what we had on the front. Okay, so I'm going to go back. We're going to solve for x. So the very first thing, if you wanted to cover up that other side, the first step would be to subtract 3 on all sides. That's how it's different. So you're still solving it the same way, you just have to do that on all sides. So you're going to end up with -8 is less than 2x is less than 12. Again, if it's confusing you, just cover up that left inequality. Next step would be to get 2 away from the x, so we'll divide everything by 2. So that would be -4 is less than x is less than 6, and then x is by itself, so that's actually our solution. So what that tells me is my solution is any number in between -4 and +6. So on these, you're going to still have the 0 in the middle, and then we're going to have a -4, which will be on the left side, and then we'll have a +6. Okay, so let's just start out by just looking at this part. X is less than 6. So we know it's going to be open on 6 because it doesn't include it. Everything to the left, or everything that's less than, is to the left. So I need to draw a line to the left. Then, let's look at this part. So always read your variable first with inequalities. So x, it's open to the x, so x is greater than -4. So it means it'll be an open point, and greater is to the right. So notice our solution is any number in between -4 and 6. They connect on the graph. So remember at the top we said and was all together. That's also another way to check your graph. It should be all together. They should be connecting when you have an and statement. If not, then you messed up on the graph part, or you messed up on your solution. Okay. All right, so let's look at 6. So 6 is a disjunction because it's separated by an or. So it's separate. Okay? So it's like solving 2 separate problems. So first step is to subtract 7 to get x by itself. We're only looking at this first one. Then we have x is less than 4 minus 7 is a -3. So we found that one. Now let's look at the next part. This one, we need to subtract 7 also. And then bring the negative down with x. Negative x is less than -6. Now on this one, we don't know x. X isn't by itself yet. So if you remember back from Algebra 1, anytime you have a negative in front of x, to get rid of that, you'll divide both sides by a -1. Remember we talked about inequalities. We're going to need to flip that inequality sign because we're dividing by a negative on both sides. So we have x is now going to be greater than -6 divided by -1 is a +6. There's our solution there. And then we have this one also. Now, when you're writing your solution here, actually I want you to do So write the 2 solutions and put an or in between it. Okay, so now let's graph it. So we're going to have a 0, we're going to have a -3, and we're going to have a +6. Okay, graph both of them. So x is less than -3, so it's open. Everything less than would be to the left. X is greater than 6, so it's open on 6 because it doesn't include it, and it's greater, so everything to the right. So notice these do not connect. So when you have an and statement, your inequality is all together, and when you graph it, it's connecting, it's all together. When you have an or, it's two separate, and then also it on your graph, it does not connect, so it goes in opposite directions. So make sure that you're checking that. Okay, let's take a look at 7. Okay, so notice we have an and statement because it's all together. But notice in front here, we're going to have a -1 in front of the parentheses. And so we're going to have to distribute that. So that's going to make it -x. And that'll be a +1. Remember, we talked about that yesterday. Always look at the sign in front. Is less than 4. So remember on the and statement, if you want, cover up that left inequality, and if you are struggling with what you need to do next. So we're going to subtract 1 on all sides. That's the most common mistake, is forgetting to do it on the left side or the right side. It's all sides. So that's going to be -5 is less than or equal. That's -x is less than 3. Then we have a negative in front of the x, so we're going to have to divide everything by -1, which means we're going to have to flip both inequality signs. So that will become +5 is greater than or equal to x is greater than -3. Okay, so there's our solution. So we have a 0, and we have a -3, and we have a +5. Okay, so notice it says that x is greater than -3. So it's not equal to, so it's open. Everything greater is to the right. And then notice that we have x is less than or equal to 5. So that's equal to, so it's closed on 5 and everything to the left. So again, those graphs should be connecting. All right, let's look at 8. Notice we have an and statement. So again, if it confuses you with what you need to do first, cover up that left inequality. First step would be to add 7 to all sides. So -7 plus 7 is 0. Make sure you write 0 there because there's nothing else with it. And then you end up with a 3 on the other side. All right, now we have a fraction. We talked about this yesterday. Anytime you have a fraction, you can do it in multiple steps or one. So what I can do is multiply everything by 4/3. Or you could do it in multiple steps and multiply everything by 4 and then divide everything by 3. So 4/3 times 0 is going to be 0. Those cancel. And then you could reduce across, so 3 and 3, those cancel out to a 1. You're just left with a 4 over there. So we have x by itself. So there's our solution. We can plug in any x value that is in between 0 and 4 and it should be true. So let's do 0 and then 4. X is less than or equal to 4, so close circle, less than is to the left, and then x is greater than or equal to 0, so equal to, greater would be to the right. So again, those should be connecting anytime you have an and statement. If they don't, then you messed up somewhere. Okay, on the last one, I want y'all to actually try that one. It's an or statement, so make sure that you get 2 separate answers at the end. And then also when you graph it, make sure they do not connect. It should be going in opposite ways.